Okay, good morning. I'm going to start the lecture because um, can't wait for much time. We have to finish many things. Right. So this is the last unit, the application layer protocols. Up till now, what we have seen is the physical layer, that is the MAC of this one. What are the mediums, access mediums, wired media, wireless media, and all communication methods in the physical first unit. Second unit, we have seen IP addresses, network layer, the jobs of network layers. The third layer we have seen, we have moved towards the software layers, that is transport layer, where socket addressing, port addressing is seen. And now actual applications, that is the fourth layer of the TCP IP model, application layer protocol. Now on your screen there are few applications which are listed along with their port numbers. Now these port numbers are very important port numbers. You might have to remember these numbers because again these are the well-known port numbers, or you can say system port numbers. So you cannot assign these port numbers to any other protocols or any other applications. So these are fixed. So 53 server uses DNS and so on. So, and these numbers are fixed till 1024 port number. And if you can use as a user port numbers, if you're writing any program, if you're writing any application, then you can use any port number which is greater than 1024. So these are the system port numbers. Let's go through a few of these. FTP is a file transfer protocol. Okay. Some of these protocols are server protocols. Some of these are client protocols. Some of these protocols have both client and server protocols. So if you have a look at DNS, so what you can say, you can see server, HTTP server and client also, and there are some protocols or applications which are supported by TCP as well as UDP, and there are some protocols which only are supported by UDP, just like TFTP. Okay, FTP is not supported by UDP. FTP is supported by only TCP, right? So these are few things you should know about the applications. So FTP, file transfer protocol, whenever you want to transfer any file, those two port numbers are used, 20 and 21. This is a simple mail transfer protocol, SMTP. It uses 25 number. The telnet is the remote login protocol. Whenever you want to log in to, let's say, server from your home or remote machine, then you should be using telnet protocol. It uses 23 port number. And as you know, HTTP, it uses 88 for client and 80 for server. So you might have to add that. Then you get DHCP protocol. Now we have seen DHCP assignment, if you remember. So these that uses 67 and 68, but thing to remember, it is not supported by TCP. It is supported by UDP. Okay. Now the reason behind it is DHCP. We'll see DHCP in a while, and I'll tell you the reason behind it, why it uses UDP only. Let's go through these protocols first. Um, TFTP is a smaller version of FTP. With FTP, you can actually transfer the movies, very large files, live recording, and so on. But TFTP is a smaller version of FTP that is called as Trivial File Transfer Protocol, TFTP. Uh, it uses minimum number of files, very less size is files, and I'll tell you the actual application that with using TFTP. Then this is, anyone knows about SNMP? So it's a simple network management protocol, SNMP. Uh, it is used for managing the network devices uh, at your institute, at your organization, at your company, anywhere. So it is the network management protocol. So we'll see these protocols one by one. First one we are going to see is DHCP and BOOTP. So now we'll directly move to DHCP. So as you know, we have seen dynamic host configuration protocol. It is used for assigning the IP addresses automatically. Okay, so so we have seen directly the application, how DHCP is used and how we can get the IP addresses at various machines. But now we will see how exactly that happens. Okay, so before DHCP, there was a BOOTP protocol. The name itself suggests that someone is booting its machine. Okay, so some machine is getting booted. So boot protocol, what it does, uh, I'll give you one example where suppose you have started a startup, you have bought, let's say, 100 machines. They don't have operating system installed on their hardware. Okay, so what you want to do is you want to install the hardware, you install the operating system on all the machines at once. Okay, you don't have time these days, go to each machine and install the operating system, because it takes uh, 1 hour or couple of hours maybe for each machine. And if you start installing operating system on 100 machines, you'll be wasting so much time, or you'll be spending so much time. And consider, if you want to if you have a startup with 1,000 machines or 5,000 machines, then it goes really bad. So what you need to do is you want to boot all the machines at once, and you want to assign the IP addresses to all the machines, so that a server can send the booting files or something like that, and then all the machines can be booted automatically. So for that, each machine should get first IP address automatically, because they don't have they have not installed operating system, so you can't configure the IP addresses uh, in any way. So BOOTP actually helps assigning the IP addresses automatically. But for that matter, what you need to do is you should have every machine's MAC address. Okay, so BOOTP actually requires the MAC address, and then it can assign the IP address. So BOOTP server, what it does, it stores the machine's MAC address, and then it assigns the IP address to that particular machine. Now, this was the basic requirement of BOOTP. But the problem with BOOTP was, it was assigning one IP address, and then it cannot be changed afterwards. So as the network has raised in many ways, there was a requirement of DHCP. Okay, where DHCP provides both way IP addressing, that is static and dynamic. Okay, now consider that, let me just draw a simple diagram here. Okay, uh, so let us say, consider that you have 1,000 machines, and let's say these 3 machines are there who are used by 3 owners. Okay, and these 3 owners are coming every day, and they want these machines as a fixed IP address. Okay, now there are, let's say, uh, another 100 people. What they are doing is they are coming every day, but they are not uh, you know they don't want the IP address, the same IP address every day. It can, if the different IP is assigned to their machine, they don't have any problem. Just like owners, let's say these 3 owners, they want the fixed IP address for their machine for some reason. So fixed machine IP address, that is one part. Then automatic IP addressing, that is another part. So these 100 people, they come every day, but they are okay with any IP address. And then there are some another 50 employees. What they do is they don't come every day, they are on the field, but they come some days in the office. So what they do is there are some machines uh, on which multiple users are sitting. Okay, if one user is coming on Monday, it sits on this machine. That employee sits on this machine. On the next day, some other employee is sitting on this machine. So actually they're not, they're just using the internet, nothing else. They are not aware of what IP address is assigned over there and all these things. So there are 3 cases where IP address assignment uh, is done by DHCP. So these 3 just a minute, let me clear. Okay, right. So DHCP assigns these IP addresses in 3 ways. One is the automatic IP addressing. Okay, the automatic IP address addressing assignment is a permanent IP address assignment. Okay, so for the owners, if you are getting the IP addressing, that is the first case we are having. That is the automatic, but it is permanent. Then the dynamic IP addressing, where the assignment is limited for some period. Okay, that means what? Let's say we are assigning the IP addresses for the second case. The IP address will be assigned uh, only for one day. Next day, the next IP addressing is assigned. So that is the dynamic IP addressing. Okay, so it will be used only for some period of time. Okay, or you can say it's a lease time. And the third one is manual IP addressing. If the user is coming on that day, if the machine is getting booted at all, then you assign the IP address manually. Okay, that is configured using boot. Okay, so these are the actual 3 ways in which DHCP works. Okay, and these are the what you can say parameters DHCP shares with the DHCP client. Okay, so we have seen the DHCP server is there who is assigning the IP address. Now there are few more terms which are assigned by the DHCP server, not just the IP address, but there are some other parameters. Who is the DNS server helping that particular client? What is the subnet mask? What is the default TTL value? What is TTL? Anyone? So it's a time to live value. for a particular message. Okay, so whenever DHCP is assigning any IP address, there is a time to live value. Then MTU is maximum transfer unit. So whenever you are assigning any IP address, you put some limit to that particular client, how much data you can transfer at a time. Okay, so that is maximum transfer unit. Then source routing option, what are the routing options you can have at the network layer and all these things. So these are the some of the parameters which you should be, which DHCP server assigns to the client. Okay, now this is a DHCP message format. It is similar to bootp format. Okay, both the formats are same. Now we'll see these fields in the message. Okay, all these fields are very important and very easy to remember. Okay, the first one is operation. What kind of operation code is there, whether it is a request or response? That means what? If a DHCP client wants the IP address, then it will be considered as a request. That means client to server. So if the message is getting from the client to the server, the operation code will be 1. Okay. If a server is sending the message to client, then the response will be 2, or this value will be 2. Okay. So it is very simple. Again, what is the hardware type? It is the whether it is a Ethernet, whether it is a wireless Ethernet or something like that. What kind of physical medium you are using? Okay, that is the hardware type. Then HLAN, what is the hardware LAN? That is the MAC address. So MAC address is different for Ethernet, MAC address is different for wireless network, MAC address is different for Bluetooth. So it depends on what kind of hardware you are using and what is the length of the address, hardware LAN address. Then it comes for the hops, number of hops which are there between the client and server. Now, when the client boots, that time the client doesn't know where is the server, so client sets it to 0. Okay. Now we'll come back to the situation. Let me. I'm sorry. Let me draw one more diagram. Okay. Now, let us consider that this is the DHCP server. Okay, and there are some machines you have bought, 100 machines, and you want to boot these machines, or you want to assign the IP addresses to these machines. Okay, so what happens? They don't have the operating systems. What they do is they get switched on. Okay, and they are completely, clueless what to do next. Okay, because they don't have any operating system and they also don't have any IP address, so they are completely clueless what to do next. Okay, so what happens is, as soon as they boot on, their physical layer gets they are all connected in a LAN. Their physical layer gets activated, and they send the message that these guys are switched on. Okay, as soon as they send this message in the network, this server will come to know that there are some machines who are needing some help about the booting or about the IP address, because that particular signal is sent to the broadcast. It is sent as a broadcast. It is sent into the network. Now, this as a client, DHCP client, doesn't know who is the father of this network or who is the server of this network. So that's why it broadcasts the message into the network. So everyone is getting the message. Only DHCP server will understand that message. No other client or no other machine is able to understand, because they are also the new babies in the network. Okay, so consider this situation. Let me how to move into the slide, guys. Okay. Right. Sorry. So, so this is the situation where client doesn't know where is the server, how many locations away is the server. So that's why client specifies number of hops as 0. Okay, and it will be incremented automatically if that message is getting transferred from network to network. As soon as you change the network, the number of hops is going to change. It might happen that server is available in the third network from where you are situated, so that is possible. So in that case, the number of hops are going to change. Now then the transaction ID, it is the random number or sequence, that random number is generated, and then the sequence number, it is getting added one after other. So that is just a identification of that particular message. Then how many number of seconds are elapsed since the client has started booting. Okay, that is very important because it will inform the server that how for since how long the client is waiting for the help. So that is the time lapsed. Then you have client's IP address, your IP address, server IP address, what is the router IP address. These are the IP addresses which are mentioned over here. We'll see the example of these values in a while. Now, when you boot the machine, this client boots up the machine, it doesn't have the IP address. So you have to specify the client IP address that is not known to the client at the moment. What is your IP address, that also is not known to this client. So this client doesn't know anything. So what are the values which are set by this client for this particular message, that we are going to see in a while. Okay. And then you have these other fields where you have to mention the MAC address, client hardware address, that is MAC address. What is the server host name, what is the boot file name, and all these things. Okay, so these are some of the other information which are needed. What you can do is you can just read out these terms and you'll come to know automatically what are the things. Now we have seen one, the basic type of the message, DHCP message. Now, as soon as you change the values, the type of the message changes. Okay, so for example, if the OP value is 1, that means it is a requesting message. OP value is 2, it is a response message. And if you have many combinations, then there are multiple types of messages. So these are the different types of DHCP messages. We'll see them one by one. Let me clear this. Okay. So the first one is DHCP discover message. Okay. So it is actually the first message in the sequence. Okay. This number will tell you what is the sequence number of the. So this has to be a first message, and it will be generated by a client, and it will be broadcasted by the client, because client doesn't know who is the server. Okay, so that's why it broadcasts the message to search who is the DHCP server. So DHCP discover message is sent by the client, and it will be sent in a broadcast. So this is very important because you might get a question which machine is broadcasted and which message is broadcasted and which message is unicasted, something like that. So the question might be for among the following, which message is broadcasted. So maybe there will be some options from this. So you'll have to choose DHCP discover, and you'll have many questions on these messages. Next one in the sequence is DHCP offer. So once this message is reached at the DHCP server, what does the DHCP server do? It offers something to the client. Okay, it is the response from the DHCP server offering something to the client. Okay, and you have to mention those other parameters which we have seen previously. Okay, those DNS server, maximum transfer unit, and all these things, TTL value. So you have to mention those parameters. Okay, so that is the second message. The third one is again DHCP request. Okay, that means it is a acknowledgement from the client for accepting whatever the offer it has got. Okay, so what will happen? You have got some parameters. Okay, what you'll have to do, what every client will have to do, every client will choose the parameters values. Okay, that you are accepted with these parameters, and then you acknowledge that particular offer. So that is the request, and then you have DHCP decline, message from the client that I don't want these parameters. I'm not agreed with these parameters. Okay, I don't want these this IP address or something like that. So that is the DHCP decline or DHCP acknowledgement. If you are accepting these what you can say parameters, then you acknowledge the particular DHCP request. Then DHCP NAC, that is the negative acknowledgement from server to client. Then DHCP release, if some client has done with the work and he wants to release the IP address, then that is the DHCP release. DHCP inform, if you want to inform, let's say you are a client and you are coming to the office for, let's say, 4 hours. You are a field worker, but you have some job to finish and you are here for 4 hours in the office. But after couple of hours, what you have come to know that you'll have to sit for more number of hours. Then what you have to do is you have to inform the server that you need this IP address for some more time. So you'll have to inform the DHCP server about the situation. So that is very important. So these are the DHCP messages. I'll tell you the examples of these messages now. So let us say this is the client. It sends the DHCP discover message, okay, to the server. Now remember, this is the broadcasted message. Okay, even if you are, it is seen that it is from the client to server, but it is actually broadcasted in the network and only server reads that message. Others will discard that message. So once the DHCP discover is reached here, server will send the DHCP offer to that particular client. Then client sends a DHCP request that, selecting some parameters. Okay, and then server has to acknowledgement that particular request. So whether server is okay with that or not. Okay, so this is the simple message transfer between the client and server in case of DHCP. Now we'll see actual the values. Okay, now when the client boots, as you know, there is no operating system installed on the client. That means it doesn't know who is the server, who is what, and that's why the destination IP address is not known to the client. So that's why it is mentioned as 255.255.255.255. So that means what? It is a broadcast address. Okay, this is a broadcast IP address, and even the MAC address, destination MAC address, is not known. So that's why it is also mentioned as FF, 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 and all these things. So whenever all the FFs are there, that means it is a broadcast MAC address. So and the source IP address, you don't know, the client doesn't know the source IP address. That's why it is mentioned as 0.0. This is not the valid IP address, mind you. Okay, so it is mentioned as 00. That means the client doesn't know what is the IP address. Okay, but you know what is the source MAC address. You know your own MAC address. Okay, so you make that entry into the message. Okay, and this becomes a DHCP discover message. Okay. Now, when the message is received by the server, what it does, it sends some offer with the parameters and all these things. But in this case, what it does, it specifies the destination MAC address. Okay, so that the message or the offer will reach only at this client and not to the other client. Now, remember one thing, at this stage, the destination IP address you can't mention because can you tell me why? Anyone? Okay. Up till now, the DHCP is not assigning any IP address to client, so you cannot mention, the server cannot mention the destination IP address. Okay, so it mentions the source MAC address and destination MAC address. Okay, and also it mentioned the source IP address, server's IP address, source IP address. So the 10.1.10.8, if it is mentioned as a source IP address, then client will come to know that who is the DHCP server. Okay, so that is the IP address mentioned over here. So once the offer reaches a client, what it does, it selects those parameters and it accepts those parameters, requesting that I'm okay with the IP address that you have mentioned. Now, at this moment, at this offer, let me just go back to this message. So your IP address is mentioned in the DHCP offer. Okay, so that IP address is selected from the pool, IP addressing pool. Okay, so once the your IP address is mentioned in this message, and if the client accepts that IP address, then what it does, it sends the selected parameters and the IP address as accepting message. At that point, again, destination IP address, actually you can make this destination IP address as 10.1.10.8 because this time you know what is the destination IP address. Even you know the MAC address, you either can mention this MAC address or you can mention FFFF. Now, at the time of accepting or rejecting, you are changing these values. If you are accepting, then you can mention these values, or if you are rejecting, then you can mention the broadcast IP address. Okay. Now, here again, the source IP address is not copied here. Okay, that means what? Let's say your IP address, which was mentioned here, your IP address is 10.1.10.10. Okay, now that IP address is accepted, but it is not assigned yet by the server. Okay, you are just accepting that IP address, so you are sending the acknowledgement that you are accepted. But as it is not still assigned by the server, so you have to mention source IP address as 0.0.0. Okay, and then the MAC address, source MAC address, you are actually mentioning it as it is. So once the request is reached at the server, then you are the server is acknowledging that this particular IP address is assigned to you, and you can use the IP address. So in that case, the destination IP address is mentioned directly over here. So in that case, what you come to know is 10.1.10.100 was mentioned in the in this field, your IP address field. Okay, so this is how these are the messages with particular values are given as an example here. Now, I would like to throw a question to you. Are there any queries among these messages, values? Okay, in that case, we can move to the next one. So there are a few things. If the client is rejecting something, if client is not accepting whatever the parameters you are sending, then you send a negative acknowledgement and so on. Another case that we have discussed is, let's say you are in the what you can say, in the office just for 4 hours, but after a couple of hours you come to know that you are sitting for another uh, some time. In that case, you'll have to increase the lease period. Okay, so what you have to do is you have to renew the lease or TTL value. Okay, so what in that case, again you have to send a DHCP request asking for increasing the lease period. Okay, if the server is accepting that, if server has that pool available IP address, then server extends that lease. Or if there are some machines waiting for the IP addresses, and there are some requests at the server for the machines who are waiting for the IP address assignment, then in that case, server sends the negative acknowledgement, DHCP NAC. That means you can't sit for more number of hours after 4 hours. So these kinds of situation might happen. In other case, if server has the available IP address, there is no request pending, then DHCP server sends the positive acknowledgement. Okay, so these are few cases of DHCP. The next protocol we are going to see is DNS. You all are aware of this one, domain name system, domain name servers, and all these things. The reason why this protocol was designed is not every person can remember these IP addresses. Okay. As you are thinking of, this 32-bit IP address, that is again very difficult to remember which machine has which IP address. So that's why you have to, as a human, you have to remember the names, but not the roll numbers. So what you do is, instead of remembering the IP address, you have to remember the name, and you have to assign the names to each machine. So that is the logical addressing which gets involved. Then, are you aware of any host file in your system? If you go to C drive, Windows, then system 32, then device, drivers, etc. I think I have not, just a minute. Yeah, so I have opened the C drive, Windows, System 32, drivers, etc folder, and there is a host file available here over here. Okay, so I have not installed any DNS on my machine. I am not using any DNS server, but still there is a one file. Okay, there is this file is called as hosts file. Okay, let me open that file for you. Let's say notepad. Okay, now this host file, before the DNS came into the world, this file was used by every person in the network. What this file does, it actually stores IP address and the name of the machine or the name of that particular device. Okay, and it keeps storing these IP addresses and the names. Okay, and you keep on adding the values as as you come to know about the names and their IP addresses. So this was a very basic database that you were using, the people were using earlier, but nowadays actually there for this job there is a DNS server, and you get plenty of many options which we are going to see in a while. Okay, the problem with the host file that we have just seen, there are only two columns. One is the IP address and one is the name of that particular machine. That particular file is available on your machine. Okay, if your machine has lost that file, or if there is something wrong with the machine itself, then you can't reach to the network. Okay, you can't go to the any other machine. So these are some of the problems. You can just go through the problems afterwards. To resolve these problems, DNS came into picture. DNS, what it does, it is a server, and it stores all the information about every client's and every IP address and every client's name. Okay, so it is stored on a single computer, and that information is sent to each client. Okay, so DNS server helps each client to remember the names, or to know the names of the IP addresses. Again, these are some of the positives of DNS. You can just go through these points afterwards. You'll come to know what are the positive things of DNS. Now, what exactly is the DNS? It is a flat naming scheme. How do you name a particular machine is very important. You can't just name any machine randomly. There has to be some hierarchy that you have to follow. Okay, so it has to be a hierarchical namespace. Okay, and these are some of the things how a name can be assigned. So how many labels you can have, how many dots you can have in a like the website name. So website name is going from www.abc.xyz.com. So how many dots you can have in a one name? How many characters should be there? What is the maximum length of the address? And all these things are mentioned over here. Okay, so this is the hierarchical example. So let us say you are in the university. You have in that university you have many departments: computer science, telecommunication, administration, and so on. In the computer science, you have multiple what you can say sections: software sections, hardware sections. In the software sections, you have multiple labs. In hardware sections also you have multiple labs. So each lab will be, or each machine's IP address, let's say machine1.lab.software.computerscience.university. So this way you can, if you can decide on your own how you can create a hierarchical name of a particular machine or a particular application. So let's say you are installing Apache web server or any web server for that matter. So what is the IP address you are getting for that particular website? What is the name you should give to that particular website? That is very important, and that this is decided in this way. This is just an example here. You can decide your own hierarchical names, okay? But when you go on the internet, this is a local, what you can say, naming system. But when you go on the internet, there are some rules that you have to follow, okay? And these are some of the things, again, you can read later on. We'll have to move uh, quickly. Always remember, if you are opening on any website, let's say xyz.com, okay, so after com there is a default dot which is called as root of all the DNS. Okay, so whenever you consider this kind of naming system, actually there is one server which is called as university server. Okay, and that is the server who is assigning the names to you. Okay, similarly, this is a local area network concept. Similarly, when you go on the internet in the world, there's a default hidden dot which is available in the name of the website, which is given at the end, but it is hidden, so it is not mentioned anywhere in the whenever you are accessing any website. Okay, so that's why it is given in the bracket that is mentioned as a hidden, but that is a root of all the DNS servers. Okay, then you have multiple options as .edu, .com, .gov, .mil, military, organization, .net, and so on. Okay, so edu is a educational institutes will have edu, just like we have mitwpu.edu. But again, it is that edu is in the country. So you have a France, you have in India, you have a UK. So under the country also you can have multiple edu or gov or something like that. Com is for commercial, geo is for US government, military for US military. If you have your own government military or your own gov.in or something like that, then our government uses gov.in. So, and if it is just gov, then US has taken that, US has that power that it can use direct gov. So these are some of the examples how internet DNS or naming system is available. So at each level you have these names. Okay, this is the original root who is providing all the names to the different levels. Top, this is the top level, and this, and then you have a second level, third level, and so on. So if you want to, if you have the this name lab.cs.mit.edu, then what it does, it it identifies as a particular machine from this lab, from this department, from this university, and this university is from this educational group. Okay, if you have, let's say we have mitwpu.edu.in, so we are going into this part, and there will be edu section, there will be MIT WPU section, there will be CS department, there will be CET department, sorry, and so on. So you'll have uh, the names of a particular machine designed like this. I hope you have got the idea of DNS. What I want from you is you have to go through these terms on your own, because these are self-explanatory terms, and I have explained many things about the important things about both the protocols, DHCP and DNS, and I hope you have understood it, and we can stop here if you don't have any questions. So by the time I am creating the attendance link, if you have any queries, we can discuss. Okay, here is the attendance link. Thank you, guys. See you on Monday. Bye.